Evaluate this line integral where C is a square formed by all these lines, and there is also a remark written over here that for partial fractions 1 divided by x minus alpha into x minus beta is equal to 1 divided by, take the difference of alpha and beta, and into 1 divided by this factor minus 1 divided by this factor, right? So this is how we can easily make the partial fractions. Alright, let's move on to the example. The C is a square given to us, and it is x is equal to -2, y equal to -2, x is equal to 2, and y is equal to 2. So this is the square C, and if I put this denominator to be equal to 0, what points I am getting? I am getting z equal to plus minus iota. Are these 2 points lies inside this circle? Yes, they are, because what is z equal to iota? It is 0 plus iota, 1, 0 plus 1 iota. You can also write this as 0, 1. So 0, 1, that is this point. This point is your iota. Similarly, negative iota is this point, right? So both the points lies inside this circle. So we can use the Cauchy's integral formula for both these points. What is fz? We always take fz to be the numerator, right? So taking f of z to be equal to the numerator, and to use the Cauchy's integral formula we also need f at iota, the value of the function at the point z equal to iota, and also the value of the function at the point z equal to negative iota. Because of the square we also need the derivative of fz according to the formula. What is the derivative of fz with respect to z? It is e the power pi z into pi, and f of iota is e the power pi iota. F of negative iota is e the power minus pi iota, right? Similarly, we also need f dash at iota and f dash at negative iota. What is that? F dash iota is equal to pi e the power pi iota, and f dash negative iota is pi e the power minus pi iota, right? Okay, this function e the power pi z, it is analytic inside this square C. Analytic means it is differentiable everywhere except at these 2 points, right? Because at these 2 points the denominator will be 0, which means this complete integrand is not defined, right? That is why this function is differentiable everywhere or analytic everywhere except these 2 points, right? So let's write this. Okay, before writing this I need to make the partial fractions for 1 divided by z square plus 1 whole square, right? So before evaluating the integral we need the partial fractions for z square plus 1 whole square. So that is equal to 1 divided by, how can I write this? It is z plus iota into z minus iota, right? And its square. So this is equal to, we know that when taking the partial fractions according to the formula, we have, what is alpha? Alpha is negative iota. What is beta? It is iota. Please remember the format. X minus alpha, x minus beta. And it is equal to 1 divided by alpha minus beta. So we have this negative sign. Please remember this format. So z plus iota can be written as z minus iota, and the another one is z minus iota. So alpha is minus iota and beta is iota. So it is 1 divided by alpha minus beta, that is minus 2 iota. Then 1 divided by first factor minus 1 divided by second factor, and then we need to take the square. Very fine. Okay, so this is equal to, okay, what is iota square? That is -1. So this is further equal to, when taking the square we have 1 divided by 4 iota square, and iota square is -1. So writing here minus 1 divided by 4, right? And the square of this, we write here a square plus b square minus twice ab, right? So this is further equal to minus 1 divided by 4, writing the first term as it is, writing the second term as it is, and minus twice. We need to make again the partial fractions for this, and we have already made in the second step. So rewrite the second step for this. 2 cancelled out, we have 1 divided by iota, and because if I rationalize this, I get just multiply and divide by iota, I get iota divided by iota square, that is iota divided by -1, which is minus iota, right? And when multiplying iota inside, or when you open the bracket, you will be getting, it is iota times 1 divided by z plus iota, and this will be positive because of the negative sign, and iota is multiplied with this, right? Is it okay? Fine. All right. Now in the next step, and now we have to multiply both the sides with e the power pi z, because we need to make this integral, right? And then integrating. So here we have now 4 integrals, also dz. This is e the power pi z dz, then e the power pi z dz, and then e the power pi z dz. So we have 4 integrals over here. And now before applying the Cauchy's integral formula for this, let's write that, let's remember that e the power pi z is your fz, which is analytic inside the square c, right? So we need to write that first before applying the formula. So it is written, since fz is analytic inside and on the given square, and also z equal to plus minus iota lies inside the c, so therefore by Cauchy's integral formula, we have this given integral to be equal to this complete right hand side. And now we are going to evaluate all these 4 integrals according to the Cauchy's integral formula. What is that? Cauchy's integral formula for simple fz divided by z minus z naught with no power is equal to, it is 2 pi iota, multiply this with f at z naught. Please remember this format. Accordingly, then you take your z naught. And second formula for the first derivative. Here we have z minus z naught whole square f at. So this is equal to 2 pi iota f. I'm having 2 over here. Just subtract 1, we get 1. 2 minus 1 is 1. So right here the first derivative at z naught, and divided by whatever be the derivative, write that of the factorial. And because 1 factorial is 1, there is no need to write this. So let's apply these 2 formulas very carefully. What is the given integral? It is e the power pi z divided by z plus 1 whole square dz over the square c. So that is equal to, we have here 1 divided by 4 with negative sign, and then e the power pi z. Please write this as your fz to match with this formula. We have taken e the power pi z to be fz. You can also write it as fz in the next step. Okay. Applying the Cauchy's integral formula for the first integral, we have, what is z naught here? Here z naught is negative iota. So this value is equal to, this integral will be equal to 2 pi iota f dash negative iota f dash z naught. Z naught is negative iota. Here z naught is simple iota. Please remember the format. z minus z naught. Accordingly, take your z naught. Okay, here z naught is iota, and because of the square, we are going to apply this formula. So this is plus 2 pi iota f dash iota. Then simple formula, first one, we have no power over here. So this is minus iota. What is z naught? Z naught is negative iota. So this is minus iota. According to the formula, the value is 2 pi iota f at negative iota. Then plus iota multiplied with this value, and the value for that integral is 2 pi iota f at iota, because there your z naught is iota. Let me take 2 pi iota outside of this bracket. Cancelling this, we have minus pi iota by 2. It is minus pi iota divided by 2, and now let's write all these values we have already calculated. So this is equal to minus pi iota divided by 2. What is your f dash minus iota? It is pi into e the power minus pi iota. For positive value we have plus pi iota, right? So for the derivatives, for the first derivative we have for minus iota. Okay, so we write here pi into e the power minus pi iota, then positive sign f dash iota, plus pi e the power plus pi iota, and then minus iota multiplied with f of minus iota. What is f of minus iota? It is e the power minus pi iota, and for positive value it is e the power pi iota. So iota multiplied with f at minus iota. So this is minus iota, and the value is e the power minus pi iota. Then plus iota multiplied with f iota, plus iota multiplied with e the power pi iota, right? Okay, so this is minus pi iota divided by 2, and now I am going to apply the Euler's formula for e the power minus pi iota. What is that? It is cos of theta minus pi plus iota sine of minus pi. Cos minus pi is cos pi, plus iota sine minus pi is minus sine of pi, right? And this value is negative 1, this is 0. Similarly, for e the power pi iota, we have cos of pi plus iota sine of pi, that is minus 1 plus again this is 0. So it is again minus 1. So we have both these values to be equal to minus 1. So pi multiplied with minus 1 plus pi multiplied with minus 1 again, minus iota multiplied with minus 1 plus iota multiplied with again minus 1. So this is equal to minus pi iota divided by 2. This is minus pi plus iota minus iota. Cancelling these two, and we get here minus pi iota divided by 2 and minus 2 pi. 2 cancel, negative negative becomes positive, and we have pi square iota to be the required answer for the given integral. What is the given integral? We have e the power pi z divided by z square plus 1 whole square dz over the square c. It is z square plus 1 whole square, right? Very sorry for this. It is z square plus 1 whole square. And also, here also z square plus 1. I'm very sorry for that. This is correctly I have written. Okay, thank you so much. God bless.